So what is this? What is this? Okay, what's this update? This is a Rift update. Sigi Watch on Rift. This is basically Sigi and Rift update. What I call constitution update. So, today we're looking at. Wait 1 second, guys. Otter AI should be doing it. Basically, I'm trying to log into Otter AI before I start. So I'm using the audio to get a transcript for this. Because Otter is 100% accurate. Basically, I'm trying to do this properly. Basically, I'm logging into Otter now. This kind of service I need. 1 second, Namji. So your stream was not showing. So let me go to Otter AI. So I'm okay. So I'm just logging to Otter AI, but I'm trying to do it properly. So today it has gone past. It's not really I haven't really clicked to record now. I do want to start recording. 9 months. Okay, let me just click record here. Okay. So this should be good enough to start recording. Okay, it's recording my voice now. There's no need for a recorder other than Audacity. That will be 30 minutes bound. So my 30 minutes is going to start now. So this is a Rift update. So I already started now. Okay. So this is my next step. So Rift is a flexible translator. Today that means you have to focus on the problem. So the problems are really the kind of conjugate response to everything. So the kind of the duality of everything. Rift homology, tomographic. So for example, you can be in a wave. Everything has a wave. Electromagnetic wave. A wave has a EM wave, electromagnetic wave. It can be waves first or electric first. But they're physical first. Things like it will just be physical, harmless physically, or harmless analog waves. But they're just physical. So electrical or static system, based on how they evolve. So basically, I'm trying to give you an idea. Rift is a flexible translator. Forever in our souls. That's me. Because I'm Mr. Heart and Soul. Forever in our souls. OBI, O for Oscar, B for Bravo, I for Indigo. Next, today's date is the 22nd of December 2025. The time now is 15th of 59. The Rift of Fractional Room. So we got the Rift repository here I'm looking at, because of the things that I can't see. Rift is a flexible translator, aka, don't you change that ever again. But we're gonna go today on the Rift spec. We're gonna try to go to Rift spec. So this is a textual specification of Rift. But we go to Rift TOML, which is like the Python TOML. But for Rift, Rift is a flexible translator. It's a tool chain that really it's basically not Yak. It's not never Yak. It's basically meant to, for example, if I'm apologetic and I'm sorry. Okay, if I'm apologetic, I'm sorry. 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 So if I say sorry once, I'm sorry. But do I mean it? That means a permission to sorry. I don't give my consent to sorry, but I don't mean it. So I'm permitting sorry, but by force. So it's like a forced duality. If I'm sorry, I'm not telling sorry. I should say sorry 3 times. If I'm not sorry, I just say sorry once. Because I was never sorry. I just fake my sorry. If I give the sorry, if I start the presence twice, sorry. I am sorry. So if I'm a producer, then we agree on consent. So basically, it rotates the plane of existence. So we are now at the same phase, equilibrium. We're now at an equilibrium. We are now apologetic. So if you say sorry to me once, and I say sorry to you once, that doesn't mean anything. I'm not apologetic because I just fake my sorry. But if I say not sorry, that means I said not sorry implicitly. So it's an implicit policy of not sorry because the policy days are implicit because if I say sorry to you once, I'm sorry for myself, but I'm not sorry for you because I don't really mean sorry. I have a half sorry, but I say sorry twice. That means I'm consent to sorry. We are both sorry. But if you say don't say sorry to me, 1-1, that means you are not sorry and you are still in a state of unsorry. Rationale, reason. That's the reason. So rationale. The rationale of this framework is for Rift, but it's let's agree to disagree. If we agree once, parity. If we agree, if we don't agree, if you agree, if you have a true and I have a false, that means we don't agree. We don't share consent, even. But if you agree once and I agree twice, we share consent. If you then give me your agree, I say okay, you agreed, You give me your half agree, then I give you my minus half agree. That means we can both agree on some kind of operation. So basically, we then define a property functor, a plus plus, minus minus. Example, and we can then form their own universe of multiply, divide, based on pi, the pi framework, 3.14, based on 45 decimal spoilers of 5. So basically, your half sorry is my fault, not sorry. Not sorry, the maximum or nil, or the nil doesn't exist via the two-way pointer, two-pointer system. The goal of this is to have the structured approach to the paradigm. For example, if you have half a genome, you have something called a genome. You get like a structure of a genome. So you have like what I call a genome structure. So you have the genomic genomic equivalent of a genome, genomatics. What is genomatics? Genomes. What is a genome? Genome is a study of genes in our DNA, the function and influence of growth, development. Yes, basically, it's a growth of a system of healing, but the system grows with the people for generations to come. That's the goal. Because the structure has to grow. But if it's just with a syntax, it's just kind of annoying. So basically, it's kind of genomics. So it's called genomics. Basically, I'm trying to have a biological encoding genomic biological genomics equivalent of the framework for BFRs that's computationally equivalent, based on gene evolution, our genes, our ontological genes. So when we the genomes agree, we are already at consent. We have no bioinformatics. We be via bioinformatics, biological ergometic. The goal is literally to have the kind of a biological system that's stable for 10% rule. So we share a 10% minimum. That means 1% at the local minimum so can evolve. Because 10 times 10 is 100, but 10 times minus 10 is what? Basically 10 times 10, 10% times 10% is what? 1.4%, 100%. But your 10%, the reason 10 times minus 10% is what? 10 times minus is minus 100%, and then we get 10 divided by 10%. Sorry, thank you. 10 divided by 10% is 0.1%, and 10 divided by minus 10 divided by so that would be some kind of 10% thing there. So we should get 10% out of it. The more we pay them, we get out. We definitely get out. As chemical state. But we have to share 100% of it. So 10% to 100%. So we know we are evolving. Never 1% because then 1% can crash down. So that's got the biological stability. Unfortunately, via the operation of determinant measures A times B, A, B, C, D, that's sharing a half from the two, so it can grow stably. So basically, the kind of thing I'm really inspiration here, the theoretical rational proof system must ensure that we are evolving. So we are basically anything that's not anything that's mathematical, that stems from the lambda calculus framework of OBNXS, which is like the inverse left one, because two integration is stable because it's stable, but it's not for the words. It has to reflect some new word problem via ontology reference point. Basically, it happens in the real world via metaphysics, via the metaphysics of our reality, the physics of the current reality, the web over here and now and here. So the goal is literally to encode the genome into the state of the infrastructure. So we have this stable thing. But this is for example, we have my pen. I don't have my pen to write. But I got my calculator here. So 10 times 10. 10 times 10 is what? 100. Now 10 times divided by 10 is 1. 10 minus 10 divided by 10. So minus 10 divided by 10 is what? Minus 1. Minus 1 divided by 10 is 0.1. So we don't want to be 0.1, we want to be 10. So you can start evolving. So anything that's 10%, after the trident model is evolving. Within the trident model, within our operations, so it doesn't matter the program language, it has to evolve from our reference point. And the proof has to be on our ontology. For example, I went downstairs, basically you exclude names from the system because there's nothing special about names. We anchor meanings. So doesn't matter what's a variable. That's the kind of meaning. That's kind of the structure to the meaning. So it maps a syntax to structure. But syntax structure is the final goal. But syntax is the final objective. So syntax is the goal. The general structure. Like it doesn't matter whether it's an adenine thymine or thymine silent sequencing gene or series gene. It must mirror ontology. Because I'm black, but there's some kind of chemical state because of all black people that we all share, because we have some kind of equilibrium. Also we keep coming back as black. It's like animals. Elephants get tusks, because they lose their tusks because you push them. For example, I was there downstairs, and A, Z, and um, uh, uh, AS, AZ, as AM, and what's his name, Mrs. M, the manager, here, literally just talk to here now. If I don't go, I don't know. If I don't know, go. But can know a lot in our observing universe. What we do, basically, our observing universe is like what we can measure that's not noise. Based on the farthest spin. But basically, if any signal comes in now from our space, we can see it. When it comes to some range, that starts to make sense, because it's not become it can be some kind of information. We can double that basically. So my goal is like model this literally as a control system, you know. Via the meta language. So this is what's called a meta language. So Rift project. This is Rift project. So we get a meta language. So this is called a meta language. So if you go read this file, technical or no, this is no one technical pseudocode in Rift. But we get this ref file, example ref file RF. So you get the RF, which is the actual executable code in the physical layer, in the physical world. But it's like you got the M ref file, but this is the ref file. So they got the meta ref file. So you get the physical world and the mind. So you use the physical one is the one that affects you biologically and the body, and use the dot meta M for the one at the metaphysics level, the mind, the soul. But in a kind of way you don't really observe it because you're always in the physical. Most of you or people here. We have to say that's kind of fun. So this is a riff file, sample dynamic system. Let S equals R. R is like the token of to match R the input value. So basically, just take the input value. Just take the matching of dynamic runtime string. Basically, this string can grow. So like if you have the number, if you have the pi, if you compute pi with some kind of data set that is heterogeneous and there are characters, you use character encoding. For example, you use dynamic system because it's basically use character. Basically, if you have 3.14 or 15, you don't use numbers. You don't use numbers in computer. You use letters. That's character encoding to do it. Which like ASCII encoding. So you have you can use any number in that set plane, but you have to give you a letter because a letter in the CB, so we know the pi letter is pi. So you can set that signature to pi because that's the idea here. So you get the input value, which is dynamic runtime system, but the input value is a character. And you get a static one, this is just the numbers. But this is x and y be dimensions. X 2x equals 1y. But that 1y is polarized. You get the right. So 1y rotated is gives you y based on sine rule. And 1y because of xy, so they work together backwards. You get a compile time string little. So the static ones are numbers. So this is sample demonstration. Let x equals r colon. R single quote right bracket string string input value input space value close string close bracket parentheses. Let y equals r big R string brackets colon static value. Basically use the restriction syntax, but this input value is it's basically like compute ahead of time as well. So it's like if you have pi to 45 decimal places, you can use just the 45 decimal places. Basically, how you want to evolve the system. Basically, you constantly can evolve. When something emerges an evolvement, it just grows automatically. Because you get like some kind of two here. This is like one same. So you get one full people. So you get someone that's looking at a path here. So say there's someone that's here looking at a path. They can go this part, go this part. No, but they go this part. They go this way. They decide to go. They this. They don't shop. How they want to go. It just makes you ground them. So instead of them being like there, so you give them the path. And just put that path in front of them. And this is basically they're already on the path physically, mentally. On the path, because there's a path there, but the path is not away from them because this space not away from them, is inside them. So that's the idea. The area is facing them, and they can go the path. They're already in the path, so it just depends what part, what point, what node they want to take to get to the destination via the alignment principle. Which is gating philosophy. So this is a function definition for related syntax. A function grid Fn is the signature. So this is a function signature, which is like a one language greet name, space name, forward bracket so we can get the space great name, open bracket. So basically this is a initializable function. So this function greet is what function FN is a function identifier. The space is a space. So it's a blank fraction. Greet the word G for golf, R for Romeo, E for echo, E for T for tango. Right name the name the space code brackets. Print print curly brackets hello plus name hello in a string hello in a string, and then get the print like you can use the manual because you can just define this any way you want, but the goal is like you have a function signature, a function definition, how you define a function in language, the function identifying name, and how you implement that function, what kind of input measurement, the kind of curly braces can be what be a set, can be like this kind of, but have to reflect the nature of the system, how the data is modeled. Based on the binary data, because you can have like nothing there, but if the data is not there, you can't get it. But you have to take the kind of the structure. So it's like literally like if it's an array in one language, but what it's a set in another language. You usually define a set. For example, you have a set in Lua, like you have like a dictionary in Lua, but how you use the dictionary is one important. Lua, how you use them. Basically, if you have like strings in the dictionary, strings in this kind of curly braces. This is an array of strings, but if you just close a string and you don't put one number, it's what it doesn't make sense to the system. So you have to put another token. So the tokenization of the system is a caveat. If you look at caveat, we all share the caveat of how we define our ontology reference, like how we refer to something, and how we use something. It's like you can intuitive, but because how we define it is based on our design philosophy. Of language. So we're moving from now tokens design. Let's identify X, assign R some input. It's lightweight token string. So this is token string. So the triplet token string, you have like you have a kind of called D plus string. So you can send information, you can receive information. But the kind of triplet string, you want something to be blocked, so to never be allowed. So basically, it's like someone is going somewhere, and someone me going to going out to the bureaucracy, and me going to Japan. I'm already in Japan in the metaphysical because I want to be in Japan. Because I want to be in Japan, and me going to Japan is not really the problem. The problem is like the money in the real world. How I get to Japan. I really call Japan about this, but they know I'm gonna come. But they don't really want to do the job, etc. But they can do the job, but I have a problem because I know the process to do the job. So if all I said was Konnichiwa in Japan, I'm gonna say it again because someone goes to Japan right now. Solve the first problem. So kind of the thing is like this problem is a problem. Yeah, this is a path here. This is a path here. Because these are two axes of a path, but it's really in front of you. So what you're gonna try to do, well, first, because this one controls kind of thin. So this is a control, which is controls. But you really got this path. This is your path in the area. If this is area of your path, you're gonna go. This area of your path, so you really got. You gotta go, but you don't know it. So it's like you get for every axis, you get two auxiliary axes. That has to go. But the path is like one straight path to go to safety. So you get one straight path. You have to double the path. So if you're already here, if you come like a straight line. You really wish get one path, but you're two people, so you have to go one for one. So you get double that, and you're already there. So you're already there where you are. When you double the enzyme of adenine thymine, because you take two half parts, but you plus them, you add them together. You don't divide them. You have a straight path, and you go to the direction. So there must be always a path to get some kind of area you can go to, based on polarity, via lattice distance. So it doesn't matter how much the distance, they construct a new path that is unique. That's kind of a thing you're modeling. So this matter the kind of basically via try the rule. So I'm walking forward. I'm always walking forward infinitely. Something moving forward. Something that always runs. Like moves forward like it runs. So you have to use so for something to run infinitely. You have to run infinitely. You have to have infinite space. For it to run infinite time, take infinite time to do. This is what is a program. In the real world sense, if there's a dog, if someone's walking if someone has infinite space, here's what infinite time. But whether infinite you get for that infinite space, you have to have infinite time. But you have to get it from the physical world to use it. It doesn't really matter because you have to get the physical equivalent of that space time. This is what it matters in your head. It's just what it is. That's how it's divided in the metaphysics. So if you get half time, you get so half space plus half space equals 1 full space in your mind. But that 1 full space is shared with your reality of 1 full time because there's another dimension you have of space time. Because my space in my head is not the same. I have half the space in my head for half the time in the world, but I have the full space in my head around me because I can observe my reality, I can close my eyes, but I cut down my senses. So the kind of system implemented is just knowledge. So this is an example of file. This is if conditional loop. If x is not equal to or greater than while true. So this like so this basically this goes to tokenization. But this is a riff file. This is like a physical like what the hardware, the firmware runs or holds in memory. Because this room you gotta be basically for the riff. So the goal. So what does the firmware hold? The firmware holds the space in silicon space. Like in the CMOS battery. So what's your firmware? Your Muco firmware. Your Muco operating system. basically you have to evolve with the whole intelligence biologically, because the firmware is like the thing that holds the motherboard all together. You have to look at actually ensure that when there's power in the system, to do the job you have to do, and evolve with the whole people that are already there. No matter if it's like on the ground, you drop it on the medium, you probably get some. You have to ensure that the alignment of the system is there. So you get the meta ray files, which are the ones that want the metaphysical, which is the waveforms. And you get the rift files, which are for the standard form. So I'm writing rift, my system is rift. So I build the rift as a fucking translator of the MA file. So you can see the meta E, M for Mike, E for Alpha, T for Tango, A for Alpha, metadata. To get metadata, biometadata, and bioinformatics. So you get the two string bioinformation based on geology. So you only need two set of information. To get the physical information in your robot, your skin that affects you, the one that forces measure your mind, space and time, and one that affects you, your heart, your auxiliary component, your reference, your what you want to anchor to, your soul. Whether you are anchored to the fourth dimension, and the three dimension here, when you hold something you own it. So even when you hold something, doesn't matter the time you hold something, you own it for that time. So it doesn't matter if you hold a space of memory, a universe space, or a universe time. You own that time, but you may not be able to even know or use it. Which kind of problem trying to solve in the metaphysical? That's why you have to use a flexible translator. It must prioritize the structure over the syntax. Your body over your body over in the physical world, and my body holds a space of the space of form here, and basically get the body. My mind holds my mental space, and then the mental space is what? The mental, my metaphysical, and you get that's the only thing you need. Two files you need, and you get the rift file dot rift. That is the policy maker. That's like it's policy because it's implicit, because they use it to construct your real world. What you should not break. And that'll give you a target output. Because the rift files is this is dot rift files. So you got a 2-bit files. You only need the rift files, but you don't want to even write in it. So everything else is separated according to what it's meant to do via the dendrites. If you have if you have a dendrites, if you have two instructions that can run at a time, two instructions can run at one time. The two instructions, two code. You need two spaces for that. So two spaces of two instructions. Two spaces for one instruction. It's like the same model here, but if you take any part they want together, and that is true. The pseudo part is a line, but the line has to be never jitter, because that means something's wrong. But you have many ways you can construct that line, that part, because it doesn't matter where you go this way to get to. If you're here, you can choose your start. Or the middle or the stop, you go in a straight line, and that's go. The triangle rule. You have 3 parts. You don't need consent. You don't need consent. You don't need permission or anything. You just walk your path. You just no matter where you are, even though you're thinking too much, you can go back to one step. So you just look at, I'm gonna go forward, because you just must run forward. You move forward. The idea is that, so you get let's identify A equals assign string, the string input, and then you get the function in that identify. So this is like the stage 1. This is what the token prints out here. So let's identify the stage is pass out. So this is the stage 0. Stage 0 is like so you get you get like a 0, 0, 0, you get the epsilon stage. Everything has a canonical epsilon stage, but we share a canonical access. So we get the epsilon access, which is like we're not sure, we don't know, we never know, we might not know. At one point in time and space, we need to allocate memory. So space-time duality is like we don't know ahead of time, because this function has no run. Yeah, we don't have this kind of resource allocated, which is space and time. But it's metaphysical space and time. So the stage is like 0, 0, 0, epsilon. So 0, 0, 0. If you have epsilon state, epsilon, so you don't have like a rift installed. you don't even observing rift artifacts. That's kind of the idea. But every stage, so you have 1, 0, 0. A stage. So you have a stage 0, 0, stage 0. That's 0, 0, 0, 0. That's like the 0. So you get access on. So the first epsilon, last epsilon is a 0. So you get epsilon on the right, epsilon in the middle, and epsilon left. So the left one. So when the right one switches to epsilon, that becomes 0. That means you are ready to start initialization left. So that will be stage tomographic 1. So the full one is split into 1/2. So you get 0.5. Or which like a 5, but you get like a 0.5, we got like the area model, so you got a half of it, so you gotta ensure it's half. So half of the area. So if you're working on the area, you have half of the area, and area is half because it's meant to show that you are ready, getting ready to do it. You're already in a state to do it. If you're half ready, I am half ready, and if you're both ready, then you already have the aesthetic of it. Because we just need to download it. Basically, it's tomographic because it's a mosaic. You just see the red, green, blue. So if you have red, you have green. If you have green, you have blue, but it's color coded, so he knows what state you are in via the terminal system. Because Rift is a meta language and metaphysical. So you run the system based on the C as well. So if grid else, so you have one, so you get one. So one is true. So when you're ready, I am not ready. If I'm 0, that means you're that I'm not ready for you. But if you're 1, that means you're ready for me. So you have to show me you're ready. So you have to like send me a 1 that you're ready, like a true, you're ready. And I'll say, okay, yes, let me give you the thing. So the thing, but you know, that's what the SIGI protocol is going to do. It's here now forever. So if you're now ready and I'm here waiting for you, where do you go? You don't need to go anywhere. You just tell me you're ready. So you send one bit or 2 bytes of information. You send your parity byte. So you give me your right your packet. You're trying to pack it, and I will like literally just give you my states too, but with some resources. That's gonna go because you know it's like real time downloading of the Rift uploading because I got my laptop there. I'm trying to put it up this day. So this is like stage 2. So stage 1 is like the pseudocode. It's like a pseudocode. See example. Rift embodies OBNX's human structure design. Code is treated as expression, not syntax as formats. It powers translation, human or machine, to understand your intent, then formalize it. So basically, your statement expression is we're gonna hold it in the space. But you know, we hold that state as a statement what you want, what you need, expression and intent indefinitely, because intent means behavior. The VM is running executable code and stored space forever. Hold space, you hold it forever. So you get intently, yeah, you get this expression. We're gonna express. We're gonna try to do. But the expression is like the boundary. You can look at the expression. Does this past expression with a behavior that's intent? Does this lattice hyper lattice hyperspace basically the meta language is only a person in hyperspace, not the physical space. Basically you got the physical space, which is a hyperspace of the physical world, but you are the full hyperspace system. You're fully hyper, but only if you're fully me talking right now, I'm putting it on the full hyperspace. So me to put it so the meta files, the M files only as a policy operate on a hyperspace, because the hyperspace is like so we share the hyperspace with the real world. So, but the meta spaces, the meta files, meta rift files, operate on meta rift files, MRF files, .mrf only represents the meta layer. That is the real world. That is like in the mind space where we can interact with the radio waves, and that's why the system has to upload and download. But it doesn't upload what on the download on the physical layer. So if you have if you switch to a protocol of physical, you are in the physical world. But there's one more you can do, and that is your heart. Or your soul. You can have like a mirror through your system. That's kind of the heart mirror. But basically constitutional model. So I want to just make sure I'm doing it for the OBNXs in Igbo right now. Because he's meant to be a mirror Igbo ontology. And give give richer structures of meaning. Such as letters you see on the screen, like you see now, via pattern version. So basically you're using the pi framework. So you compute pi to 45 to 15, 30 to 45 decimal places for each evolution as a policy, because you have to know what it's gonna do if it's gonna evolve. Because 30 might not be stable. Just because for evolution, so it has to be middle, because that's why it's there. So it must be stable as the maximum step. So Rift tokenize example the back. So this is example the back file token. So this is file. So you compile to Rift tokenize, Rift parse, Rift analyze, Rift generate, and Rift emit. Basically this compile. I have these files on my GitLab repository. But I have to go download all my files today. So the policy is like a policy wrap ox security. So this is a policy defined, but you define it in the Mexican language. So you got a function transition data, send data. But this first is sees the policy, decorates wrap and wraps locate automatically. So it translates it into 2 systems. So this is like a pi. This is like the time. So you have a Python. It's like a policy system. So you have define a wrap function. This wrap is a decorator. It's a meta decorator. So you have the policy. That's why the policies matter, because it decorates systems. But it allows you to. So it generates the function transit. So this function generated is a transition in transit. The data is transition, and the if auxiliary data equals return 1. This is equals send data return 0. Return an integer, transit that take a counter pointer to the data. So the pointers are the same thing for the array of data. This represents an array of characters, but this one represents an array of characters in any row alignment, and you get the pointers to a pointer, represents a major pointer to some kind of 2 pointers. Now basically you have 2 pointers to that. That's really what you need. So you never need 3 pointers because 2 pointers is actually down to 2 pointers maximum because you have 2 pointers means you have 2 dimensions. Of 2 dimensions of space on or time, and 2 dimensions of space of time means you have either 2 data sets that is 1 dimension, that share 1 dimension, or 2 that run 1 time because it's just 1 mapping. So basically, the goal of this is like have the meta files only work lock it down to the metal and the physics layer for now, but you got the riff tomo files. So basically, this code here, you can the type node value match data based on the code. But a basically, if I have as a policy, I'm not trying to do it. But if you open a file, I'm basically gonna stop this thing. Stop because I just stopped my Audacity export. Browse document. Sorry guys. Rift. That's kind of idea here, then. So guys, I did it. So basically, do you want to see the project in the council? Let me just post it twice. Because I don't trust myself. So basically, this is done. I hope it is done the way I want it to be done. Untitled or Rift. So we got Rift. So let's go on pictures. Let's just save in music. Music or videos. Music or Rift. Rift today. Rift MFR. So the meta files are only bound to physical. Basically, you have the tomography one, so you have some from coding there. So you have a string code because there's some for everything. So you have your trident, I have my trident. But we are meant to ensure we share 1 trident. So if you're not sure about something, I'm sure about it. Because the trident is a problem. It's nothing like the kind of input we have. It's just how we see each other ontological reference point. What we want to do. So we share 1 trident. This amount of my trident like this. If I'm like this, if my trident is like I'm going up and I'm pointing trident up, I'm pointing straight up. But if that's my like my trident, so I made it so that one can work and how me too, because that one's like point at me. But if I double my trident, if I keep my trident half, like smooth like this, it doesn't hurt my soul. But if I extend, the right, if I check the right thing, it has to polarize at the right thing. Let's try to record again. Basically, I'm trying to do this for base 64 too. So basically, that's what I'm going to do. So the R syntax in Rift is really the go-to for the system. For because you don't need so you got the meta RF files, the RF files, and you get the Rift files. But I don't want for packaging. So you got the tomography package. So you got the Rift. So you got the configuration, but the configuration is already package. Basically, the configuration is an on-the-fly package execution. It allows you to execute what you need to execute. It doesn't matter how bad you type the code. If you can execute, it starts to store that thing. So that is the Rift doc or semantic version F. So you get the Rift tomo. So this tomo is very important you have, because this is like tomo. This is the master switch. So this is the master switch. This is the master switch for a self system like Python. This is membrane. This is like the dimensions. But this is like a tomo because it's Python tomo files that they use. But this is like a macro. So this is a macro. This is example macro. Macro row. So you define something called a macro row, but basically you have the inverse one for what you define. For example, if you define a function, you define it backward. You define what you even need for a function first. You define what you intend for a function does. So you have the intent expression but you don't define what the function will do first. Because if you define what the function will do, that means in the row order you define what the function is running. And when the function executes is going to be problematic, which is a big problem we're trying to address in Rift. So this works all the way backwards. Doesn't matter how you package it. You have to know what you're doing first before you actually do that thing. Which is why you observe something a state first, and before you intend. So you don't know. So when you have a function, we don't see functions in the real world. So that's kind of idea. You don't have a concept of a number first. You have a concept of what some kind of thing before you think of a number. You have some kind of category. You categorize so something that's rememberable. It doesn't matter what it is. You just have something before you start understanding the concept from abstract to physical, from theoretical to practical, etc. That's doable. It's kind of a doable thing. There's no what in the metaphysics. You don't really think about what you're doing because you just do it. You just do it because you just want to do it. Then you start thinking about what you're doing because you are processing, and that'll be what the problem is. Your person wants you something for it to come full of picture. You don't want to. So what you see is like the single project grow without the people growing. You have to grow for the people without the people knowing it's growing. But you always check you're growing it with the people. That's kind of idea. This is a single protocol. But you know, it's be bound. So all the rational proof has to be bound to dimension game theory. But you know, if you go here to references, you get all the system. Here, oh my days. So basically it's now done. So you get basically you get the single protocol, and this is what I'm trying to get you to read. So you get the markdown version. This is the Nisiki here now. So basically the single protocol it's a metaphysical and it's a physical. It's which was 3. So if you get that 3, for example, if you get a real file stage which is binary equivalent, binary equivalent. So you get the binary ones. You get 1 1 1. So you get 3 3 3. So you get a parser. So you get stage 0 0 0 is what Lexa done. But that's a working Lexa of the Nisiki Lexa. N for November, S for Sarah, I for Indigo, G for Golf, G for Golf, I for Indigo. And you get the Nisiki parser, which is 2 2 2. Now, the Nisiki parser is like I have to know it's doing because I pass correctly, based on the kind of metaphysical reference that there. And the Nisiki is like a protocol here and now. That's here now. So you have all the space here. All the space to do something. That means you're in bytes, in parity bytes. So for every parity sequence, for every 8 bits, for every 8 bits, so for every 8 bytes, you get 3 parity bits stored for storage and time. Parallel, so that's the idea. So you get shared bytes of 3 bits. You get 3 bits of information. So you encode it. So you get yes, no, not sure, because you know the parity can be polarized for the area. It doesn't matter what you're doing in the area now. So if you have an area, you get for 8 bits of information, you get how many parity bytes? 8 times 3 is what? 8 6 8 6 9. So you get 9 parity bits. 9 bits 9 bits with a shared problem from me, myself, and I, based on the segment memory for space, so you can heal yourself. This is a state transition framework, but it's really a protocol. It allows you to from A to B. This is a mosaic. It allows you to lose interest in the job, because you know it doesn't matter how much hacker, but you meant to ensure that you're literally This is a Markov chain, but it's a Markov chain. So it's a Markov chain because you know it's meant to give you doesn't matter. So if you just touch something, if you like if you see some artifacts, some kind of fab, and you know you see something, you really have the full awareness of it. But if you want to control, you have to touch it. But if you have the touch command of hidden artifacts in .git, I'm gonna give you git files. So git tracking. So if for example you don't have to get the git files here, yes, the GitHub. You have to get the GitHub. You know, don't see the git header. You don't track the .git when you upload the. But if I say you have .git here, you know that's really seeable. But this is meant to be hidden. Because you know that means the tracking state of the whole artifact is broken. So the idea here is to just look at if I'm writing touch, that means I'm what writing to it. I'm reading the file in .git, like some file dot. If I type dot touch space .git / you see all the files there already, because you see all the files there. That's the problem there, because you observe it and you cannot action them, but you have to see this. You have to use so if you use ls. So I'm saying the touch command is equal to ls. So the listing. So in the terminal, in the Muko shell, like in the Muko shells, you meant to ensure that you don't see this kind of problem here, because you know you read what the state of the system only bound to the execution context, because you don't want anything touching the wrong information. For example, this is what I call getref. So this is what I call getref, because getref does the same thing. So for example, if I do ls dot get / such that get this is getref. Get is a regulation framework. So this is a security protocol here. So you get now I'm here. Who says it gets because you know you see you observe the state. You know you want to. Doesn't matter what you do. You only track what you need, and that's the kind of state of it. You need basically the command you're executing. Which is the code here? The policy here. Because the policy are explicit, but they have implicit guards. You know, basically the policy are implicit, but they have, because they're trying it, they have explicit guards. It's like blowing a bubble, and that bubble has some kind of shape. Basically, it's like blowing a bubble that's going to become a rock. But that rock is my bubble, because I can leave that rock, that policy system, because I don't work for that system. So that's kind of idea. So this is like the RAF problem. Git dash regulation as file or RAF, or git init RAF, which you can download this repository. Open this is get RAF. Problem 1. No, who gets govern? a legacy system, I'll just share the vibe. Rift Alpha. So basically, this is like a custom model. I'll just show. So the show is like the governor. Who governs governor? Who gets the final say? Governance is governed. Basically, if something works for everyone, no need to change it. If something works for everyone, it's like having some kind of circle. Describing this. Basically, as a policy, let's just construct namely a circle. Look, for a world, it's a sphere. It's a sphere involving some kind of cube, some kind of triangle cube. Because we can be here, here, and here in the physical. Because you have to go your path. We have to all evolve. So there's no cube there. We have triangles and circles in this sort of game. Because I can see everything in one state. One state like this one, like this of state I'm in. Here maybe, but after because I have to start observing the metaphysical. I have to start. The sense is there, and it's something I can pick up. It doesn't matter what's outside or not. I can pick up based on my reference point, right? So you have a 3-way pointer, but the auxiliary pointer is like is one that's context switching. So basically, it doesn't matter what you're doing. The one that's all the stack pointers are there. So you have two. You have one at the base. You have two foundations. You have two strong foundations. Like me, UK, and Nigeria. But you have two strong foundations. And you have one pointer. But basically these are pointers. So for every two things you're sure of, you have one thing you're unsure of. That's the thing. So if you're sure about one thing, you're sure about another thing. You're not sure about another thing. If you have yes, you have no. But that no can be no, yes, or yes. But you don't know it. So you have to say, am I redoing this task? Am I going to do this? To allow you to like two problem keys to problem one keys. And you get this one. Problem 3. Who's final say? Who when the policies crash? Clash. Who's two policies are valid. One runtime path. Who wins? RAF. Telemetry. Who gets the final say? Because it's telemetry by design. It doesn't matter what it's a 3D model because you have an area, the tomographic area to cover via the Rift test, and that's why it's important to have the Rift test in the Rift ecosystem. Because this is like the Act 1. Git commit -m chore in it. Welcome to the Rifters. Now to breed. Add policy type. Basically, I can make a policy up. We can all define our reality, how we govern ourselves. But whoever wins, we have a shared calculation state of how we want to govern ourselves, and that's how we are. That's my utopia. Oh, that's my utopia. There for you guys. I hope I've done the sounds well, guys. Ebo guys. If you read demography, get rid of demography, get rid of this way. So the Drifters way philosophy is like you get my SU list here, namely. What's that? So get a SU list, get the Rift, the Gusty like so this is next. So after Rift you get I'm trying to build what Rift stage 3. Because if you're sure if you have to do this 3, you have -2 for human and so you get things invalid. So you get if I can run the code and ASU will run the code too. This is not the AI system. -2 means an AI solution which you do it. So you get -1, -2, -3 or -0, -1, but you get epsilon, negative epsilon. And for negative epsilon, negative epsilon, that's minus. So you get the test by minimum at the best case. So if I have a 0, there's a minus epsilon in this AST. AI is doing sometimes a human out the loop, and the human on the loop is one actually doing the work to fix it, to rebuild it, and that's what you don't want. So you want to just make but you want to cover that area of via polarity. So if the AI is a -3, you have a 3. Because 3 is the parser stage, so that'll be what you're gonna do. And there's one more stage you gotta do, the 3. So anyone new can come in. So anyone can write the code. So the AI must teach the AI systems, and the humans will teach. So everything about the system. So there is 3. So if you have a 3, I have a 3. Something that's actually growing up must have a 2. Must have consent. Have no consent to do it. So my 3 plus 3 is 6. But this will be also 3, which is 6. 3 plus 3, 3, 7, 8, 9. Make it 9. So this will be a 3 by 3 matrix. Which would be like, it doesn't matter whether the person is broken dumb or not. They must be able to learn Rift. And that's what you're going to teach. That's what you're teaching your PhD on ontology. Because they must be able to run Rift code. If you can't run Rift code in the metaphysical layer and they're blind or deaf, then you are failed. Because you are autistic too. And that's what you're going to give. So that's the policy now. So we need to try to bring it to metaphysical layer so we can log in with the eyes. It doesn't matter. So if I'm in the room, if I'm in this space and my computer is here and I want to log in and I think I'm going to log in, I should be able to have some interface in my mind that's really there to signal me, okay, now he's he wants to log in. But so we don't have mind time deviation or craziness. So we can have it's kind of thing. Because if I hold a space, that means it's my space, but I hold it for time. So if I hold a space and time definitely, that means I hold it indefinitely. It doesn't matter if it's BFM or if it's physical or not. It is my space and time. I can go back to. It doesn't try to formalize. It doesn't matter go travel astral project. I hold that space and time at all times. Because me thinking I'm in the UK, I'm in Japan. I'm in UK, but am I in Japan? No, I'm in UK. But in the physical, but for me in the metaphysical, I'm thinking about Japan. I'm going on holiday. I'm in Japan already. Because I'm not thinking about anything I want to do in UK no more. I'm thinking Japan. Because I hold Japanese metaphysical space. Or BFM. No, I think about BFM now. How do I go to BFM? I think about BFMs. I think about the future of BFM, and then I think, oh yes, there's a way I can go there, and that's in my metaphysical and my physical before I go to Japan and go to BFM. So Japan give me a PhD, and I don't think about one. I think about the context for change. Which like the goal the tax want to do. So it's not lexical tuition. It's not lexical tuition. We show share calculus of lexical how we pass, but the constitution is like what we want to do with our pauses, and that's why it's brief stage 3 manners. Okay, Namdi, thank you.